Hello everyone. Welcome to the video lecture series of complex variable. I'm Mayur Gohil. In this video lecture, we shall be taking up the following question to find the analytic function whose imaginary part is vx comma y equals to e to the power minus y sin x, and we also find its real part. Now let us see how to go about this question, and in this question I will be trying to show you certain steps in which you will be able to skip some steps which are very generic or very redundant in nature. So let us see. The first thing we write, let f of z equals to u plus iv be analytic. Therefore f dash of z is equals to ux plus I Vx, and so we have the formula Vy plus I Vx, right? This is the formula for f dash of z that we are going to use. Now we calculate the partial derivatives. Write down, we write here, given v x comma y is equals to e to the power minus y sin x. Okay, we now calculate the partial derivative Vy, that is daba v by daba y, which is going to be sin x times e to the power minus y into minus 1. Okay, this is how it is. So this is what we get. Now what we do is, we do not put any labeling over here. We will just directly get the thing. Now vx, when we do, now see, vx is going to be daba v by daba x. So when we get that, e to the power minus y is constant and sin x derivative is cos x. Okay, so we got this. Now we write down the function f dash of z. We don't go for any labeling part over here. We just put the values vy. The vy answer is sin x multiplied by e to the power minus y multiplied by minus 1. That is the answer. Okay, and plus I times e to the power minus y cos x. This is what is now important for us. This is the first step, this is the second step, this is the third step, and this is the fourth step, which is very important for us in this portion. We are not putting any labels or anything. Okay, now the by Milne Thompson method, we write here, by Milne Thompson method or Milne Thompson method, we put x equal to z and y equal to 0. So therefore f dash of z is equals to sin z e to the power minus y is now e to the power 0, and then there is minus 1, plus I times e to the power minus 0 times cos of z, right? So that is what we will get. So now we substitute here f dash of z. Now let us simplify this. After this substitution, let us simplify this. What is going to come? So it is minus of sin z plus I times cos z. That is what we get here. Now let us perform the integration. Integrating both sides with respect to z, we get integral f dash of z dz. It is minus, here if we integrate here, integral sin z plus I times cos z dz, and when we integrate here, we will, on the LHS we will get f of z, and on RHS what do we get? Let us see. Integration of sin z is going to be minus of cos z. Okay, so here it is going to become plus cos z. Okay, and here it is I times sine z. Okay, this is what we get. Now, if we simplify this a bit further, this is cos theta plus I sine theta, so it is nothing but e to the power I z. This is the answer for the entire thing, and we can even keep here the constant of integration c as the term. So this is our final answer for the question that was given to us. Okay, so this is the answer. I'll put it in a box. This is what we get. Now we are also asked to find the real part of this function. So let us see how to go about it. I will now write the function here. So the function that we got was f of z is equals to e to the power I z. That was the function that we had got. So what we do is we put f of z is equals to u plus iv and z equals to x plus iy. Therefore, u plus iv is equals to e to the power I times x plus iy. Now, what do we get here? We get e to the power ix minus y, right? And this will become, we can use now laws of indices, so it is e to the power ix into e to the power minus y, and this will become cos of x plus I sine of x, right? And here it is e to the power minus y outside. We multiply the term in, so e to the power minus y into cos of x plus I times e to the power minus y times sine of x. So u plus iv. Now LHS is complex form and RHS is again a complex number or form, so you can compare them. So therefore we can write here like this: on comparing LHS and RHS, we get u x comma y is equals to e to the power minus y cos of x, and v x comma y e to the power minus y sine x. So our answer what we wanted is this, but this comparison gives us two answers. So therefore we write down the real part of f of z is u x comma y equal to e to the power minus y times cos of x. Okay, so that is what we get here. So that is the answer for the question that we have taken. Now, what I want you to know here, very important thing is that here when we are doing all these kind of questions, in this question I have for the first time not written those names psi1, psi2 and all. Those steps are redundant. If you solve many questions regarding solving for imaginary and a real part and all, you realize that they are redundant. So what you can do is, instead of labeling them, you can directly substitute them in f dash of z, and then you directly write Milne Thompson method, put x equals to z, y equals to 0. It is very much clear. You need not do that labeling of the step. That can be omitted. It is again not going to affect the answer. Okay, it is just a matter of presentation or the matter of making an algorithm. Okay, so here then the standard procedure of integration and finding the answer will work. Okay, I hope you have followed this example. Please go through the entire example carefully, how the whole procedure is done, and please digest the whole steps. And I'll soon see you in the next video lecture. I hope you like the content. Please share it with your friends, those who find it useful. Please subscribe to my channel, hit the like button. I'll soon see you with your next video with a new topic on the same series. Okay. Until then, keep solving good amount of mathematics. Thank you.